Okay, thanks for waiting. And good afternoon. I'm Jenny Shanker from the Michigan Center for Student Success, and you are joining us for our
Our
uh, quant- quantitative reasoning co-requisite supports webinar. This is part of a series of 3 webinars focused on co-requisite support courses for the mathematics pathways in Michigan. So we have one on the preparation for calculus pathway, one on statistics, and then this is the final one on quantitative reasoning. We are archiving all of these on our new website, miwritemath.org. So if you're not able, for people who are not able to join live today, we will have this recorded, or if you're on live and you want to go back and refer to it, it will be available later this week. I want to thank Becky and Jeff for joining us and presenting the content for this webinar. And for their introductions, I'm going to turn it back over to Paula from the Dane Center.
Hi, I'm Paula Talley from the Charles A. Dana Center at the University of Texas at Austin. I am the systems implementation lead for the work that you're doing in your wonderful state of Michigan that Jenny is the facilitator for. I have on the line Jeff Morford from Henry Ford College and Becky Menig from Ivy Tech Community College. They're going to talk about their quantitative reasoning co-requisite support courses and the design of their courses. We have 2 different ways that they're implementing their courses, so we thought that would be helpful to bring that to you. I also want you to note that I will have you on mute because we are recording this. If you see your chat box, you can kind of toggle at the bottom of the screen. You can actually see your chat box, and I'll send a response right now. If you have questions, just go ahead and type into the chat box. And periodically, depending on how many people we have online, we might have some time for some live conversations. And I am going to turn it over to Jeff first.
Thank you. I appreciate the chance to share our program. We're still very early in our process. This is our first semester. I think that you'll find it valuable nonetheless. And if you're interested in success information within a semester or 2, I'd be happy to share it. My contact information is at the bottom of the slide, so if you need to get a hold of me, that's how. As mentioned, I'm going to emphasize why we chose the cohort method, since Ivy Tech does the co-mingle method. So as we go over each area, that'll kind of be where my focus is. And I just wanted to let you know in advance, I just discovered the auto design feature in PowerPoint. So I apologize if I overused it, but I think you'll find it an improvement over my old style, which was light blue background. So I think we can go on to the first slide, Paula. So our typical pathway, there were pilots and short-lived other things, but generally a student would take beginning algebra, which we call Math 80, and then in the subsequent semester they would take Math 131. So beginning algebra is the prerequisite for this course because that's the prerequisite required in Michigan to have this meet the Michigan transfer agreement. We run this as a single class. So the registrar has folks sign up for this Math 031 and this Math 131. The students have to sign up for both, but we just 3 hours twice a week. The students are with us and we do whatever we need to do to get them so at the end of the semester they can pass the Math 131 objectives. In order to make that work, we do have a seat time requirement, which it won't at this point, but it could cause some of our students to pass the Math 131, the college level course, and fail the Math 031, which is just a pass-fail course because of the seat time requirement. Right now, there's what you would expect, students who aren't attending class. There's not many, but the students who aren't attending class aren't doing well, no matter which is the cause and which is the effect. I think many of you have seen this in your own classes. In fact, I started out with 29 students, 2 have dropped, and 6 are having trouble with seat time right now, but the 2 that have already crossed the threshold already don't have an A through C in the class. The Math 31, we handle it pretty much like we handle our normal quantitative reasoning course. The teachers have minor constraints, but it's nothing big. You know, homework can't be more than a certain percent. The final exam must be a certain percent. But within that, you can do whatever projects, quizzes, and tests you think are necessary to meet the goals of the course for the students. And we've added a little bit of program control in that as one of our assessment projects at the college, we're sharing a common question in each chapter. Part of the reason for this is we found that some of the success, from semester to semester, the success rates were varying from 70 to 90%. And so we wanted to get a little bit more consistency in the course. On the next slide, I'll talk about why we're doing it. First of all, we thought it would work. The data's been encouraging from states that took this on a conscientious, thoughtful way. You know, some states had to do that because their legislature said, you best think about this because these are the rules now. Other states moved together. Michigan, most of the names I saw, I haven't checked the participant list lately, but we're Michigan folks. Most of you probably know that we have basically no state system. So we sort of are undertaking this college by college with great leadership from Jenny Shanker to try to bring us together, and great support from the Dana Center that way. We also at our college had already done this with beginning and intermediate algebra, so it wasn't brand new to us. And that isn't exactly how our cohort model's working, because I'll tell you a little bit more about how ours works for Math 131, which is also how it works for our statistics. But in our algebra, they largely do all the beginning algebra topics and then do the intermediate algebra topics and just do it in one semester. But both the registrar and the other faculty in the department were used to this idea, which I think made it easier for us. And by persistence, I'm not talking about persistence in the student sense. I'm talking about 2 years ago, I brought up, hey, wouldn't it be a good idea to start exploring pathways? And 18 months ago, some other faculty started bringing up some of these co-requisite models. And by a few of us repeatedly at every meeting bringing this up again and again, I think by the time it came time to actually adopt this, everyone assumed it was a foregone conclusion or that we'd already agreed to do it. So if you have the time, I recommend that you just keep bringing it up again and again, and people will believe they've already decided and they're used to the idea. So we did have some advantages in our program, primarily that a lot of the registration hurdles that you might come across the first time you do this were already taken care of by the intermediate and beginning combination that we had. And so a little bit more detail about how we did it's on the next slide. And we weren't calling this a pilot, but we thought we would just offer one section because we didn't want to have a whole bunch of 6-credit sections running with only a few people in it. But you can see that our plan sort of blew up there. That's a picture of our plan blowing up. And what happened was a couple things. One, this is popular with students. The fact that you can complete in one semester rather than 1 year, I mean, in hindsight, that should have been kind of obvious to us that would appeal to students. The other thing is we thought we were kind of ahead of the game, where we would create these courses and then go talk to our nursing faculty and then go talk to our criminal justice system about the best pathway for them and their students. They sort of jumped the gun. Our criminal justice program is one of our bigger programs. They started accepting our Math 131, our quantitative reasoning course. And nursing surprised us a little bit because nationwide, most nursing programs are going with statistics as their to meet their mathematics. They chose quantitative reasoning. So over the last year, we've had to change a lot of sections from being intermediate algebras to being quantitative reasonings to meet the needs of our students. So when this happened, our administration, to their credit, said, okay, we'll add a second section. And not only that, since this is the first time through, to keep things synced up, we will pay the part-time teacher involved in this a half an hour a week to meet with the full-time teacher so that we could keep this coordinated. And I would recommend, at least for the first time through, that you have some kind of coordination like that. I think it's been very helpful for us to, as problems come up, know how to address them together, and to make sure that the assessments aren't exactly the same, but that we have about the same degree of difficulty in our assessments, that we have about the same balance between the developmental portion on our assessments and the college level portion of our assessments. So I think it's been very useful to have that. In the fall, we're going to expand to 3 of these cohort classes, and I can't imagine it doing anything other than growing. One upcoming challenge that we will have with a cohort, so if you're thinking about cohort instead of commingle, our part-time teachers are allowed to teach 9 credits without coming into the full-time bargaining unit. This is a 6 credits because we have the cohort. So they either have to, our part-time teachers either have to make the choice of only teaching 6 of 9 credits, or our administration has to make the choice of allowing them to get quite a raise to get to 12 credits. And I think both of those are somewhat unlikely. So this is something that we're going to have to watch and think about as we go forward, just as a practical matter. Well, so how did we decide what to do in the support part? And what had happened is, for a short time, we had I guess you'd call it a quantitative literacy course that fed our quantitative reasoning. It was an alternate pathway to introductory algebra for a short time. When we first created that, we looked at what skills were needed in the Math 131, and then what do students need in order to be able to do that. So a lot of linear growth, and then from the linear growth, you could get to exponential growth in the Math 131. So we needed something a lot like the graphing of lines in a traditional beginning algebra course. That had to be part. Solving equations, using formulas, and then some other things that I don't think are always part of a beginning algebra course. They might be part of a pre-algebra, but percentage growth was something that came up a lot. And so again, we had another piece of good fortune in that we'd already created that for our quantitative literacy course. We were able to take those and just use them for our Math 031 course. We generally deliver it just in time, and we can sometimes do it in really creative ways, because one of the first things we do is linear growth in Math 131. And in our Math 031, if we were to try to commingle with that, it would be, I think, a lot for students who hadn't necessarily been ever exposed or recently exposed to graphing lines to try to learn that at the same time they're talking about linear, and then the next day exponential growth. So we can spend about a week or 2 weeks just doing in that class what we would do, something like what we would do in a first algebra course, not do any of the Math 131 content, and then the week after that, since we have an extra hour in there, catch up on the Math 131 content. And what I was saying, we can be very creative. You can actually, if you're careful about the problems you choose, you can actually pick problems where they don't have to solve equations when you're making the graph, and you can actually have them able to do a little bit of linear modeling with very minimal equation solving skills, and then do the equation solving skills just in time when you first need those. So if that was probably the primary example of when it was useful to have that half-hour meeting between the faculty, is just to make sure that we were both thinking of all those details. If you want to try to graph lines before you've really done a whole lot of equation solving, you better be really careful about the problems you're picking. The other thing that we do, and I think a lot of groups do this no matter whether they're commingling or doing a cohort, is part of the extra time we have, if we're not teaching a developmental skill, we will do sort of a homework lab at the end of class, and then students can ask their individual questions at that point. And just a brief pause and remind folks that if you do have a question, if you type it in the chat box, I tend to get on a roll. And so if you do have a question, just go ahead and type it in the chat box. And I think we're going to have plenty of time at this. So this, I think, repeats some of the things I said on the other slide. But so what you might do, what we do early on, so this maybe should have been in the opposite order, because we graphing equations in two variables for about a week and a half, and then we can talk about linear growth in the course for a couple days. And then before we can actually solve exponential equations, you have to solve linear equations. So we can then go for a week, week and a half. We have some flexibility. Talk about solving linear equations as though it were a first course in algebra. And then we can have students solve exponential equations after a little bit of work on what a logarithm is. And whereas you can, in the traditional 131, assume to some extent that students can solve those linear equations, we have to develop it. And there was a worry that if we commingled, would we be pushing things too much for students who hadn't necessarily had an algebra, skills. And then a typical day in the class is that we'll start out going over homework, however you go over homework. What we've been doing is giving students a little bit of time to work together and having groups suggest the problems, but you can go over homework however you go over homework. And then we do whatever developmental things we need for that day. So recently, when we first solved equations, I didn't need solving equations with fractions in it. We do a little bit with the normal distribution. And so if you want to get the measurement from the z-score, you have to solve an equation with a fraction in the denominator. So one day we spent an hour on that, and then we went into the lecture itself. And then again, at the end of many days, not all days, because we've got that extra hour built in compared to a normal Math 131, we'll do individual homework support. Sometimes there's an exit requirement, meaning that if you complete these certain number of problems, you can leave without taking the attendance penalty. I don't usually use that. Pedagogically, I don't really I use it for focus, because I don't want them to do the problems in order. I want them to maybe do one in each topic area. So it's really used by focus. Many students stay the whole time. They've sort of been pretty good at self-selecting if they need to stay to the end, or if they have an A in the class and they get the exit requirement done and leave. They've actually been pretty good about knowing which group they are in. The other teacher who teaches this has had to be a little bit stricter on that, and either made the exit requirement have more problems in it, or just said, if you don't have an A or a B, you're staying until the 3 hours are up. So you do have to decide what's going to work best for your students. And as I said, there were some days or even weeks where we did nothing but developmental work so we could prepare for the next topic in the college level course. And then we have a third version. We don't require our teachers to use projects, but most do. And since we were working together, we've synchronized our projects in the math, in the co-requisite course. And so we have days where it's largely lab-based. Most of the projects have some Excel component. And that's not really the theme today, but if anyone's interested, if you email me, I'll be happy to share what we have. I think they're what you expect: exponential growth, a mortgage rates one on Monte Carlo methods, one on creating a grade book. I think if you've been to conferences recently, you've seen a lot of things just like this. And then another thing that we talk about, that I hear about, is rigor. How do you make sure when you're mingling or when you're not mingling that you're going to have the correct rigor? And we're using the same projects that we've used in just the college level course in the past. The final exam, we do not have a common final exam for quantitative reasoning, but I'm going to use essentially the same final exam that I've used in previous semesters, and I've gotten my colleague to agree to that. So only the college level material is going to be assessed in math in the final exam. The chapter tests and the homework, we didn't feel we could do that because the students had invested a significant amount of time in some cases on the developmental work. So the chapter exams do include some of the developmental material, and the homework is obviously whatever you're going over. My colleague has some quizzes built into her syllabus. They're largely done online, and they're also mixed. Also, one final thing, of course, we would love if everyone was intrinsically motivated, but some of our students need the extrinsic motivation. And so by putting some of the developmental problems on the homework and on the test, you get them, the extrinsically motivated students, their extrinsic motivation to do that. The data isn't real data yet because we're only about 2/3 of the way through our first semester. But right now it seems encouraging. If the semester were to end now, 18 of the 29 original students, 18 of the 27 current students would be successful. There would be 9 students who would not be successful. The D gets a little bit of an asterisk because it would allow students to graduate, but it usually, if it weren't a program requirement that maybe requires a C, 3 students are not successful. 2 of them have basically stopped attending, and 2 students chose to drop the course. 1 had real attendance problems, and 1 was just not being successful. Typically, we've had about an 80% success rate. The early semesters of Math 131, we only had 1 or 2 sections, and the pass rate was closer to 60 to 70%. Recently, it's been closer to 90%. I hate to admit this, but early on when we had that 60 to 70%, I was the one teaching the course. I think part of what was going on there too is one of our big feeder schools, a lot of students would come here to take the course and transfer back. So to try to cover for myself a little bit, I think we were getting a lot of students who maybe weren't successful at their other school and then came here to try to take it. And I mean, we'll know soon enough because now that we've got a large group because of the nursing students, we'll know whether it's got something to do with part-time versus full-time teachers, or whether, you know, it was the demographics when we only had a few sections. We'll know a lot more soon just because our program has grown so much. I don't have the data from my co-teacher. We haven't had our meeting the last couple of weeks because she's become involved with Gateways to Completion, and they just had their conference in Houston. So I'll probably have that soon also if anyone is interested. And wow, I timed well. When I timed it earlier today, I had it at about between 20 and 25 minutes, and I think it was about 21 and a half. I'm happy to take questions now or later if, you know, when comparing the 2 systems, folks start to get some questions.
Yes, if anybody would like to ask Jeff a question, you can either you can unmute yourself and ask, or you may type in the chat box. So we'll wait just about a minute as people are kind of gathering or thinking if they're going to have any questions. Okay, I don't see any coming up. So, oh, but here we go. You have 1 up here.
We don't do them. So the question was, how do you handle developmental topics that don't connect strongly to the college level course? So for instance, we have systems of equations and factoring in our beginning algebra course. Systems of equations, it kind of comes up in a little bit in the college level, but only in the sense that you'd have y equal, you'd have the dependent variable isolated, and students don't really view those as systems anyway. So we can sort of treat that as an equation, set the 2 sides equal, and you don't need to develop all of the systems. And things like factoring, they're not going to come up. So we just don't teach it.
Thank you, Jeff. And Becky, okay, you have the controller. You're good to go.
Yeah. Oh. think my mouse is going rogue now. There we go. Okay, I am from Ivy Tech Community College in Warsaw. So if you're not familiar, Ivy Tech is a statewide community college system in Indiana. So we have approximately 45 campuses statewide. So that's something to kind of keep in mind as we're going through things. So when we started our quantitative reasoning pathway, I guess, it was about 5-6 years ago. And so we got a committee together and we really started with what are the big QR topics that we want to cover? Because until we really know everything we want to talk about in that course, we couldn't build our support course. So we started with those big QR topics, and then we said, okay, how can we build that connection from our college level course to our support course? And we did a little bit back mapping so we could really see how they would connect. And that kind of answers the question that you just asked about the developmental topics. And Jeff answered it exactly. If it didn't support the college level course, it got cut out of the developmental course right away. That support course became pure and simple, just help and support to pass the college level course. And so then we had the big questions of how are we going to structure that support course? Are we going to say, okay, everybody needs to learn the same things, those skills they need to pass the college level course? Or are we going to run it more of an individualized course where every student gets what they need and they might not need all the same? And at first we were unsure of how we were going to really do that. So we started first semester, first of all, Ivy Tech's model, I like that, Jeff, we both use Math 080 as our support course there, or at least we did. So our QR course is 3 credits and 4 contact hours. And then our support course is Mathematical Principles, which is 3 credits and 3 contacts. So our students are in class for 7 hours a week. And starting this fall, we are going to pilot a lot of 8-week sections. So in the math area, we are very nervous of how 7 contact hours, which becomes 14 contact hours in an 8-week section, looks. But these are statewide standardized courses. So if you are taking a quantitative reasoning mathematical principles co-rec at Ivy Tech, any campus, you're going to be using the same shells in Canvas, the same exams, same projects, same everything. So they are standardized across the entire system. The first year with our support course, we decided that we wanted to do structured. So we use those topics. These are the topics they need to be successful in Math 123. Great. So every student is going to get these topics in this order on this day. And it was horrible. It was one of the biggest failures we've ever seen at Ivy Tech. Students hated it. Instructors hated it. Our pass rates were horrible. Students were dropping left and right. And we were putting students in a box. We were saying everybody needs the same thing on the same day, and we know that's not correct. Every student has different needs. So we really decided, okay, that wasn't work. We don't want to put our students in a box. We want to meet them where they are. And so year 2, we said, forget the lecture, forget the agenda. As an instructor, you're going to come in and you are going to be student-centered. So whatever your students need, that's what they get. And there are 12 students in the class. You might have 12 different things going on. And that was what we wanted to do. It led to a lot of student engagement. Students liked the class. Instructors, even though it was a little more difficult to teach, really enjoyed it because it was more fun. Students were learning and they wanted to be there. And our pass rates went through the roof. So that was great also. We also added soft skills. So time management. We do a calendar activity where students have to actually plot out when they're in class, when they're working, when they're taking care of their kids, whatever, so that they can see how much time they actually have to study. And it's eye-opening for students because they think they have all this extra time. And when they actually look at their days, they realize, wow, I have to organize a little more. We also make them talk about their math story because math anxiety is huge. And with getting students to talk about why they're afraid of math or why they hate math, it's really liberating for them. We have that conversation and we kind of, that's your past, not your future. And we help them work through that kind of stuff as well. We work on study skills. How do you study for math? How do you practice for exams? We work on that throughout the semester. And then after, we have 3 exams. So after each of the first 2 exams, we make them do a reflection. So they have to actually write sentences about why they missed problems. So they have to look at their exams, why they missed it, and then analyze and reflect. So they can't just say, oh, I missed number 2. So they have to go through and we redo every problem. So we do the test corrections and then we make them figure out why they missed it. Because if students understand their mistakes, they're less likely to repeat them. And that has been very helpful, at least on the final exam. They seem to not make the same mistakes twice. So year 2 has now become year 3, 4, and 5. This is now the method that we use for our support course. And like Jeff, we do start with questions. That can be content specific or just homework questions, anything and everything. We like to reinforce previously taught topics, especially focusing on the meaning. You know, quantitative reasoning, we want the students to really understand. They're no longer just sitting down and, you know, plugging and chugging in a calculator. We want them to understand why they're getting the answers they're getting, how they're getting those answers, and what does it mean. So we do a lot of writing in our courses, mostly sentences, short paragraphs of really interpreting what the math tells them. So that is a skill a lot of students don't have. They've never had to write about math before. So we do a lot of that in the support course. It shocks me how many students have no idea about math vocabulary. So we make that a priority of the support course as well. We have 3 projects in our course, all very heavy in Excel. And we have Excel homework assignments throughout the course. So we do a lot of Excel practice in the support course. And then past exams and reflection. So the instructors. When we started this, our goal was to have full-time instructors teaching both sections. We thought that would be fabulous. And then we said, okay, maybe not full-time, maybe just the same instructor teaching both courses. And then it came into a credentialing issue, because to teach Math 123, you have to have a master's degree. And to teach the Math 080, you only need a bachelor's. And we do not have statewide enough master's level mathematic instructors. So we now have, almost always there are 2 different instructors. Every once in a while I get to teach both sections, but it's not very often anymore. So we have a lot of communication, and Jeff mentioned that as well, that it is crucial when you have 2 different instructors working with the same groups of students that you really communicate so that you know where your students are. And as an instructor in the support course, you have to be ready to teach a mini lesson on any topic on any given day. And I find that to be fun and challenging. So if a student asks me a question about something I taught 2 weeks ago, I have to be ready to jump in with new examples and be able to teach that. Homework questions. We use WebWork, which is by the Mathematical Association of America, for our online homework system. And it's not very user-friendly at times. So and we only use that for the college level course. But if you're the support course instructor, you also have to be aware of those problems, how it works, how to help students. And so that can be tricky as well. It's important that our instructors know Excel, at least for the purpose of the course and what we're doing in the course with the assignments. In math, we all know there are multiple ways to teach certain topics. But it's important that if you're in the support course and you are previewing an upcoming topic, that you're using the same terminology, you're using the same methods that the students are going to see in the college level course. Because if you're throwing 2 different methods at them, for one, these students might already be confused about math. And now you're showing them 2 different things by 2 different instructors, maybe on 2 different days, but you're trying to say it's the same thing. So it's important that that communication piece comes in between the 2 instructors so that students don't get confused. We want to make sure that we help them, we don't hinder them. And one thing that I'm always shocked every semester is that I always have in my mind, okay, this is what we're doing in 123, so I should be about right here in 080. And every semester there's at least one student who comes in who, you know, is 3 levels down. And I have to go back way further than expected. You know, we have to talk about inverse operations. We can't even solve a proportion because they don't even know that multiplication and division are opposites. They have no idea. So we have to go back and talk about all kinds of different things. And that's a challenge to really be able to meet the students where they are. And sometimes it's way different than where you expect them to be. I jokingly say you need knowledge of every known calculator because we do not specify to students what calculator they can use. They can use anything. So there are a lot of times 12 different calculators in the room and you have to know how to use them all. So that might be the hardest part of teaching our support course, at least the most challenging. Now we can do all of this individualized learning because we do cap our support course at 12 students. And we do this because we use the commingling in our college level course. So all of our courses, well, most of our Math 123 courses are capped at 24, which is our room capacity. We have very small classrooms. So if we're going to use the commingle, we want half of that college level course to be college ready and half to be support. So the nice thing is we have a nice small support course, which allows that one instructor to really be able to work with 12 students one-on-one every day. So depending on how large your class is, that individualized learning might have to be modified slightly. You know, if you have a class of 30 in an hour and a half, you can't work with 30 students individually in an hour and a half. It's just not possible. So there's different things that you could try depending on the length of your course and the number of students in the classroom. So as I mentioned, we do a co-mingle model, but we also cohort. So I feel like we kind of do a mixture of these two because our 12 support course students go together from the support course to the college level course. So we call it cohorting because they go together from one course to the other, but it is commingled because our college level course has both college ready and support needing students in it. I would like to try a course that is completely cohorted with 24 support needing students. Rigor is the issue. You want to make sure you don't, dumb it down for lack of better terms, but you want to make sure you keep it at the level that you teach your normal college level course. But I think it could be very beneficial. I find every semester my co-rec students, they're my strongest students at the end of the semester. But they should be. They're spending an extra 3 hours a week in a math classroom getting extra help and working on how to write it and how to understand it and all of these extra pieces. So if I could have 24 students who are getting that extra support, I think that class could be really powerful. I'm just never going to be able to do it here. That's okay. So how we figured out our content, we back mapped, which I think is pretty common. But we always started with the QR. We definitely, we also had a math literacy course before, and we cut out a lot of pieces when we went to the QR. We had our learning outcomes, and then we said, okay, we need to just slash things. Whatever they don't need, let's get out. And it was interesting, and we're still kind of tweaking those to try to make it better for students, what they really need, what we added as fluff, because I think we started with a lot of fluff in our course. So I think in that case, don't be afraid to make changes later. Your course on, the first semester does not have to be your same course in semester 5. So if something's not working or there's a topic that you're hitting that's not necessary, don't be afraid to bring that up and have a conversation with your colleagues because you do want your course to continue to improve. And that's what we can continue to do. We have meetings, we talk about it. We want to make sure that it's best for students. So in terms of back mapping, we also work on our activities. So we do have, I think there are 7 homework assignments throughout the semester that are Excel based. And then we have 3 projects. And our projects are pretty extensive. They do a lot in Excel, and then they write at least a minimum of 1-page paper, and they have to do some analysis of their Excel document. And so just an example, the project my students are working on right now deals with just some basic statistics, but they're given 150 data points, and they're going to calculate. This is all in Excel, so they're using Excel as the calculator. They're finding the mean, median, mode, range, min, max, quartiles, percentiles, all those fun things. They're going to convert, they're going to do some z-score work in there, create frequency distributions, with the bins where you have intervals and all that fun stuff. And then they're going to have to create bar graphs and histograms depending on the data. So all of that is the Excel portion of the project. So you think about, okay, if that's what they're doing in the college level course, what are we going to do in the support course? And you can see a lot of that is Excel. Do they know where to find the formulas? Do they know which formula to use? Because if you just go to percentile, there's like 8. So which one do you use? And so just being able to recognize and talk about the difference between the formulas, the graphs. What's the difference between a bar graph and a histogram? Why is one used when one's not? How do we do that in Excel? It says bar graph, okay, how can we shrink the space? So all of those little pieces that it's kind of the how-to. They know what they're supposed to do based off of the assignment in their college level course, but the support course is really the nuts and bolts of how do they get their hands dirty and get in and get it done. So we do a lot of that type of work in Excel or in the support course. And I never let them use their project data. So I would give them maybe 20 data points and we would find formulas. So we would basically do a second project in class because I'm not going to do their project for them. I will help them with all of these pieces, but when it comes to the project, they have to go in on their own and actually recreate everything that we did together. But it's all about finding that connection and how are you helping the students be successful? Because that's, at the end of the day, that's what we want. So our materials, just to go real quickly into that, we use a homemade workbook for our 123 course. I don't recommend that. But so the first 2/3 of our workbook is basically what we do in class. So everybody in the state goes through this workbook, including online students. And then the last third of the book is extra activity pages for our support course. So they match up in content. So if students come into my support course and they say, you know, we're really stuck on Z-scores today, we can just flip to the back. We have extra examples. We can talk through them. A lot of adjuncts don't feel comfortable creating their own problems. So having those resources there allows anybody who's teaching the course to have easy access to additional examples anytime you need them, which is good too. Oh, sorry about that. Resources. So as I mentioned earlier, we use a homemade packet and we use WebWork, which does not have any built-in resources. So we, the faculty of Ivy Tech, have made all of the resources that go with our material. And I highly recommend this. Even if you use a published workbook, anything, your students will like stuff made by you. And I'm talking about, I have an entire YouTube page, just math videos for Math 123 and 080 at Ivy Tech. And I get emails constantly from students around the state loving my videos because I tend to cuss periodically in my videos, or my phone rings, or somebody walks into my house. So I have all of these real life things. And so it's not, you know, cut dry. It's not boring. And my students like it. It keeps them awake. They're short, they're to the point, and it helps them when they're at home. Also, in order to have this course online, we needed videos to go with our workbook. So if you don't think you can make videos, you're lying to yourself. And if you want more information, I would love to tell you how I make my videos so that you can go do it for your students, because they will love it and it's fun. So we have statewide organizations in Canvas. So anybody in the entire state teaching Math 123 is in an organization for Math 123. It's huge. And that has exams, projects, extra examples, extra anything you could want or find. It's all housed there so the students or faculty can find it. Same for Math 080. And then we have statewide shells. So we use Canvas, and these are preloaded by our instructional design team. I don't know if that's possible for any of you, but it's fabulous. So we have people who create the shell, and it's kind of just an outline, right? It's a skeleton, and everybody gets the basic outline, and then you can individualize from there. So because we have statewide courses, we also need those statewide pieces. I think I hit a button. Paula, I might have broken it. I can't get it to go to the next page.
Okay, yeah, I think you clicked on my my other work that I have going on. So let's see if I can get it to come back up.
Sorry.
No, it's okay. Can you see the PowerPoint, or did it stop sharing? Let me do a stop share real quick. Becky,
I thought everybody needed a break from my voice.
Oh, look, I can see everybody on the line now because it went off. Okay, so let me go back to the PowerPoint. And do you see your PowerPoint yet?
Yeah, it's right. It's that last one that I did. So if you could just play from the current slide, that should work.
Okay, and then now do you see, question, which screen do you see?
Yeah.
Do you see the notes screen, or do you see
you'll need to hit swap displays.
Okay.
We'll call this halftime. Everybody needs a break.
And now that I'm sharing screen, oh, here it goes.
There you go.
Sometimes it pops up on one. And now let me pass the remote back to you.
Thank you.
Okay.
I'll try to not hit that button again.
Okay.
Okay. So what our support course should look like. All right, we want engaged students, conversations, collaborative learning. You do not want a lecture-based class. That's boring. I mean, think about it. You don't want to sit in a lecture. You're probably bored right now listening to me talk. So you want conversations, collaborative learning. You want your students working together, talking about math. Anything that you can do for hands-on activities will make it so much better. So something that I like to do, stock market, right? Because we're in a computer lab for my support course. So I make them look up for a week, and sometimes they have to do it at home because we only meet twice a week. But they have to pick any stock they want and record the value every day. So at the end of that 7-day period, then we can calculate absolute change, relative change. We can do percent increase or decrease. What does that mean? If you invested this much money on the first day, how much would you have now? So we can do all of these different real life examples with absolute and relative change. That's way better than any boring example we have in our book. And they actually will understand what's going on. So anything like that that you can put in your class is so much better. We also want soft skills. At first, when I was told that we were going to do this, we were going to add these things in the course, I'm like, really? This is a math class. We don't need this stuff in there. And then I taught it for one semester and went, wow, that makes a huge difference. Like, I think every math class could benefit by adding these skills in, because students come in with the mindset of, I hate math and I'm not good at math, and therefore this is just going to be another horrible semester. And by adding these different pieces in, growth mindset, talking about their math anxiety, it makes a difference. It gives them a different perspective on the math, and that's huge. And I've already talked about those things, so we'll just continue on. I'm also a big fan of reinforcing the skills that they've already learned. So I call it spiraling. So if they've talked about something 3 weeks ago in the college level course, I like to bring it up again and maybe just throw an example at them, because we want to make sure they're, retaining the information that they learn. It's not just learn it for the test and then be done. That's not how math works. So I like to make sure that we're constantly reinforcing the skills that they have learned in the previous weeks. It's important to preview what's coming, especially the vocabulary pieces. I never want my students to sit in the college level course and say, I don't know what that word means. I want them to come in knowing the vocabulary that's going to be used. It makes the class easier. And I always give them question answer time, sometimes too much. I also sometimes give them homework time depending on what's happening in the course. And the biggest piece that I think, no matter what you take away in your support course, it's all about support, right? You are there to hold their hand and be nice to them and let them know that they can do it. And sometimes that's hard for me because I don't always like to be nice. But, that course, the whole purpose of it is to get them through the college level course. So what can you do to help them be there? And sometimes they just need somebody to talk to about their working 2 jobs and taking care of 4 kids. And they just need a support system. Forget the math. They just need somebody to talk to. And so any kind of support that you can give your students is crucial and very, very important. And that's the key takeaway. When I did this talk for California, they had the real issue with faculty buy-in. They had a lot of math faculty who had no desire to work with quantitative reasoning or the co-requisite model because math is calculus. And that right there, we have to change the perception, because quantitative reasoning is not calculus. They are very, very different. And, I was a math major, so I love calculus. All the calculuses, they're all fabulous. But quantitative reasoning is not calculus. And for our people who are not going to be math majors, quantitative reasoning is a better math course for them, right? They're getting real world applications that they can actually go use when they leave college. And so I think we need to start changing our thoughts about math courses and who's taking them and why they're taking them. And that's crucial. So we still have faculty at Ivy Tech 6 years later who refuse to teach quantitative reasoning because they think everybody should take college algebra and calculus. 6 years later, and we've had great success and students love the class, but they won't budge on their mindset. So it's not easy and it doesn't always work, but I think that's something we need to start doing. When I say we, I mean everybody, to think about mathematics in general. And it really, for me, I was a little hesitant at first when I first saw our quantitative reasoning course, but I was open to make small changes of, okay, I'll change the way I teach. Okay, I'll change the topics. Okay. So I started making small changes until I started seeing the student reactions. And I think that's what really helps, is get faculty involved at some point. Development process is great if they're trustworthy, because we all know that's an issue, right? But get an instructor in the classroom and let them work with students and see the difference that this class can make, because that is, to me, that was the selling point. The first time I taught this class and I had my students react to the different things we were doing, it was like, this is why we need this class. And if all else fails, we can use data because we're math people. So after the 5 first semesters of full implementation at Ivy Tech, our pass rates in quantitative reasoning, college level course, increased by 36.5%. So our pass rates just blew up. But think about it, we also threw a bunch of students who were considered not college ready into that course. So we flooded the course with ill-prepared students, and our pass rates went through the roof. So it just gives you something to think about, that this co-rec thing is positive. Somebody just had a chat. Are we doing questions at the end, or can I answer that now? Does it matter? Paul, I'm looking at you. You're muted.
Go ahead and answer it now, Becky.
Okay.
Sorry. Just a quick question though. Did I swap screens? Because I was trying to unmute myself and we both have access of the mouse. So.
Oh, sorry about that. Yeah, you did swap screens, but I can swap it back if I have control.
Oh, you can do it? Okay. Yes, go ahead and answer.
Okay. The support teacher feel prepared. I actually have a slide on that, but yes, we do a lot of in-house training at this point. So unfortunately, the first 2 semesters, we could offer stipends like Jeff is right now for our adjunct instructors to help get prepared. But now it becomes, it's really, I guess it's up to the support course instructor to be willing to work with the college level instructor. But we have the organizations where we support, or we supply all of the materials, including more than we ever use. So there's always extra materials to pull from. And we also have online, I guess they're webinars. We have different videos of walking through the course, where things are at, all of those things. The credit hour split, they're both 3 credit hours, but the quantitative reasoning is 4 contact hours. So we're hoping to change that in the future too, because I don't think we need 4 contact hours. It really depends on how you structure the course. But I don't know how big your campuses are, or how many people you have that are going to teach this course. But I'm a big fan of working smarter, not harder. So when you think about, okay, we're going to be teaching 25 sections of quantitative reasoning by 13 different instructors, does that mean 13 different instructors are creating a shell and creating homework and quizzes and exams? Because that's a lot of work. And so if you can get together and have some, I call them campus champions, of people who are willing to work together to organize the course and organize the materials, and maybe get that the adjuncts or whoever's teaching the support course, get some material to them, that just makes everything easier down the road. And I mean, if you're all doing your own thing, that's not helpful. But when you have somebody who their job is to organize the homework, then if you have a question, you know who to go to. It's no longer, I'm on an island by myself. You have a village. And that's how Ivy Tech does it. So we have 5 statewide champions. One for the face-to-face quantitative reasoning course, one for the online quantitative reasoning course, the support course of Math 080. WebWork is our online homework, and now we have a statewide assessment. We just started that this semester. So these 5 people work together a lot. We're all over the state, so we have a lot of webinars or go-to-meeting meetings where we talk about the different pieces, what needs to happen. But if anybody has a WebWork question in the entire state, they email Ben, because he knows what's going on with that. If anybody has an online 123 question, the email goes to me and I take care of it. So we constantly are updating the shells and adding different things and changing the resources and whatever else needs to happen. But that way we don't have 80 people around the state doing the exact same thing. We work smarter, not harder. And now we have campus leads. So we have 45 campuses. So every campus has a lead. This is not a paid position. This is you volunteered because that's your job. And they do the training of any new faculty that come on board. We have a lot fewer new faculty now than we did at the very beginning. But that's training for the quantitative reasoning course and the support course. Either one is done on campuses. We do have a statewide committee. It's got between 15 and 20 people on it, depending on the semester. And we meet at least once a semester, go to meeting, and then about every other semester in person, where we just talk about the courses. What do we need to change? How do we make it better? Because we don't want to stay where we're at. We want to constantly get better. And then if we're making big changes, like we restructured our online course this year. So we had a subcommittee of 4 people and we got together to make those changes. So it's constantly finding people that are willing to put the time in to help you make something better and working together. I find that works really well. And then the training, our first year. So year 1, remember how horrible it was with our support course? It was just as horrible in the college level course because this quantitative reasoning, we were told, you know, your students should do a lot of group work and you should be doing collaborative learning and active learning, but nobody really told you how or showed you any resources or gave you anything. So after the first year of complete disaster, our administration said, okay, go ahead and train people. So we had a committee of about 6 people who went on a statewide tour for about 3 weeks between the spring and the summer semester, and we trained faculty. This is where you find all of your resources. This is how you teach the support course. This is how you can teach the college level course. These are the best practices. These are some skills and drills and all of this fun stuff. And it helped because then people didn't feel like they were alone anymore. Now they had at least a face and a name that if they had a question, they could reach out. And they had some ideas. So that really, really helped on that. We don't do the tour anymore for training. Now it's just campus wide. So, and the campus leads organize those trainings on campus. So, all right, after talking a mile a minute, that's it. So, any other questions?
Okay, Becky, I'm taking back over control now.
Okay, sounds good.
Yeah, so if anybody has questions for Becky or Jeff at this time, feel free to either type them in the chat box or feel free to just unmute yourself. We have a small group, so you may unmute yourself as well.
One came in via chat right between the 2 sessions, and it was about credentialing of teachers. And because we have the college level component, we also have to have the teacher teaching the entire thing be credentialed to teach the college level course. So that is one thing you have to keep in mind if you're going to use the cohort model, is that if you have some teachers who may teach at the developmental level but may not teach at the college level, they're not going to be able to teach these courses.
That is true, because with our commingling, our courses are 2 separate. They get 2 separate grades. They are 2 separate times. They're linked in Banner, so when you sign up for one, you have to sign up for the other. But because they are 2 distinct courses, we can have, you know, a bachelor's degree instructor for the developmental course and then master's level for the college level course. So that is a huge difference.
My question's for Becky. I was wondering, so when I was looking at the numbers for the support course where there's 12 students enrolled, it strikes me that like the developmental course that's comparable at our college is capped at 22 students. And so does this effectively double how many sections you're offering of these developmental classes? And has that been any problem administratively with staffing or paying salaries of more faculty or anything like that?
You know, at first we thought, yes. We thought, oh my gosh, we are going to have to offer so many sections. It's going to be horrible. We're going to have to hire people. And at the same time that we did this co-rec piece, we also went to Math Pathways. And so, and we went to a customized AccuPlacer. And so we have new cut scores. And it seems that more students test directly into quantitative reasoning based off our cut scores. And we actually don't have as many in that support course as we originally thought we were going to. So because we went to Math Pathways, we cut out 2 of our previous developmental courses and went to 1. So because of all of those changes happening at the same time, it didn't really affect that. However, it could, depending on how you're changing things, yes, which could cause problems.
Thank you.
Yep. But if I can just continue on there for a second. If you have a class of, let's say, 22, you could have that be 2, if you were using our model, that could be 1 support course with 22 people, and then that could split and go to 2 separate college level courses. So you could essentially still have that co-mingle college level side, but not have to worry about paying 2 different support course instructors and just have 1.
That makes a lot of sense. Thank you.
Yep.
And there are a couple of questions in the chat box. I'm not sure if those are to Becky or Jeff or both.
I think we answered all of those.
Even the credit hour split? Okay.
Yeah. Yep.
Sorry, probably when I was trying to take control back over.
That's all right. And I'm willing to share anything that I've created for our courses. So if you have any questions, just email me and I'll get you anything you'd like.
Okay. Jenny, do you want to close us and tell us where this recording is going to actually be then?
Okay, thank you. Am I unmuted now?
You're good.
Okay. We will be posting these on our new website, which is miwritemath.org. So spelling out right math using MIRIGHTMATH.org. As soon as we can get the recordings rendered, and then we're starting a page on that miwritemath.org called the Co-Cadre Resources page, and so that's where we're going to put these webinars and also any materials that people would like to share, things that they use in their class or syllabi or anything like that, that Becky or Jeff that you might like to share with us, and also anybody on the webinar who's doing this already and would like to share some of that. So we'll there'll be a spot on there for resources, and you can just send them to me. My email is jshanker@mcca.org. But easily, Paula can put you in touch with me if you have any questions. So thank you for being with us. Thank you, Jeff and Becky, for spending time with us this afternoon talking about your programs. Exciting stuff, and everyone have a good week.
Thank you.